to introduce John Edison Munoz Cordona, who is a research scientist and game designer. And John is interested in using human body signals to create more humanized assistive technologies, and all that based on games and interactive system. And so John has put together today's panel. So thank you very much for that, John. This is not the first one, first panel with industry experts that you have put together. So thank you very much for doing so. John's research has been applied mainly in the healthcare scenarios, from physical activity promotion for seniors to neurorehabilitation games for stroke patients. John has received his PhD at the University of Madeira in human-computer interaction, and he's passed, his other degrees are in electric engineering and physics engineering as well, from Columbia. I could go on about John and his accomplishments, but I think I will do better by letting John speak to the panel and the panelists that we have today. I will disappear at this point, and I will come back at the very end to close things off. So John, over to you today.
Thank you, Agata, for the introductions, and thank you all of you for coming to this panel. Today, I'm happy to have this very diverse and scientifically rigorous panel in today's seminar. So we're going to be talking about some of the things that we have been enjoying and we have been seeing progressing with the time, which is how to build sensors, and in this case, head-mounted displays, working with virtual reality and augmented reality, and how to put body sensors into it, and how to record those signals, and what is the importance of doing those things. So with me, I have three very brave people that have been, starting their own businesses, people that have been joining startups, and scientists that are actually believing on this new generation of head-mounted displays and technologies. So I will let them to basically introduce themselves and their own specific companies. So I will start with Sarah, and Sarah is coming from Cognition. Sarah is actually from the University of Waterloo, and she's now with this very exciting company doing augmented reality and putting together some brain-computer interfaces to facilitate and to create assistive technology. Sarah, go ahead.
Thank you very much for the kind introduction, John.
I got here this video in which you can see the device that you guys have. So I'm going to mute it, but I'm just going to play it for a couple of seconds.
Speech language pathologist, and this is the Cognition one.
So the video goes like that. So Sarah, go ahead.
Okay, thank you very much. Again, thank you for the kind introduction. So I'm the biosignals engineering lead over at Cognition. So our company is developing a brain-computer interface that uses EEG signals to acquire brain waves and then apply artificial intelligence to drive an AAC device. And AAC stands for augmentative and alternative communication. And it's a type of medical device that's used to supplement or replace speech for those with speech impairments. So just to go into a little bit of my background, I have my bachelor's degree in knowledge integration, and I have a master's degree in systems design engineering, both of which are from U Waterloo. My specialty and sort of where my biggest contributions are to this space is mostly on the biosignal processing side, a little bit of interface design, and sort of the machine learning algorithms being used to translate the brainwaves into speech to drive the interface.
And she is now partially driving all the future of this very exciting technology that has been around for a couple of years, and she is located in Toronto. The next participant and panelist that I have is Brian. I met Brian a couple of months ago when we started developing some games for Luxid Labs, and I had the pleasure of having the headset that the company is creating at home, and I actually tried, and it was really impressive. Brian.
Hi, my name is Brian Te, and I'm from Luxid Labs, and we are actually located in South Korea. And my major was bio and brain engineering for the master degree, and for the bachelor, I majored in computer science. And I quit the a postdoctoral process, but my major was machine learning. So my dream was translate the user's mind to the in the computer and brain, like a brain computer interface. And at the time the virtual reality comes up, so I decided that making some brain computer interface in the virtual reality is very cool. So I made a kind of the brainwave sensors and eye tracking sensors for the brain virtual reality headset. And but last 2 years we are very focused on the healthcare applications. So when people playing the games, we want to capture the user's cognition level and the other brain health levels. So now we are making Lucy, and we are preparing some applications and the home care system in virtual reality market. So thank you.
Great. We will talk about those applications in a couple of minutes. Last but not least, Charles. He's coming from all the way from the UK, and he is the CEO, and he's been working as a chief scientist officer in MTech. Charles.
Thanks, John. Yes, so my name is Charles Nduka. I'm actually a surgeon by background, and how I came into this whole area of human-computer interaction was through a desire and a need to help patients with facial paralysis. I studied medicine at Oxford University and at Imperial College, and did my middle degree in psychological disorders. So I've always had an interest in mental health, but the main problem I was trying to solve was finding a way to help patients to get feedback on their facial expressions for their rehabilitation after having had surgery to improve their facial function. Now, when I started that work back almost 10 years ago, then when the Oculus Rift first launched, I realized, wow, the potential of adding this technology to VR headset would give an unparalleled insight to how a person was responding to what they were seeing or hearing. This because EMG has been used in research for 3 decades now to understand implicit responses, automatic responses to what a person is experiencing. And but it's been quite a challenging journey because the face is flexible, it varies a lot in size and shapes, and has a lot of challenges. So we have our system, which is integrated into a VR headset, and our main uses at the moment are for academic and commercial research, but also we have a number of healthcare related projects working with partners. We have 2 EU-funded projects, as well as a number of other collaborations in the commercial sector. But our main goal really is about health and well-being.
For those that are not really familiar with some of the concepts that we are here talking about, we're mostly discussing physiological signals. So body measures, the measures of the body and different parts of the body, and especially electrical responses, electrophysiological responses of our body when we are interacting, in this specific case, with extended reality devices. So we'll be talking about virtual reality and augmented reality. And with that, we can actually jump to the first, leading question, which is, for those that are not really familiar with the physiological signals, body signals, I would like, you to try to more or less bring your pitch or talk, try to convince people, why do we care about physiological signals? Why are those signals important? And here I'm just showing a couple of those signals that you guys have put already in some of your devices, like electroencephalography, recordings of the brainwaves, facial electromyography, allowing us to record signals from our face, and also eye tracking devices that are coming now already in some of the virtual reality headsets. So why do we care about physiological signals, Sarah?
I'll tell you why we care. Well, our physiological signals, they give us a window into like what a person's health or what their intentions are when their body doesn't do when their body is otherwise unable to. I think when we talk about like biosignals, we kind of think about it in the context of healthcare and like diagnostics. But for me personally, what I really care about is being able to use these kinds of biosignals to decode and interpret what someone's intentions are. I think we can agree that it can be really difficult to figure out what someone's intentions are just based purely on their actions, alone. And I would say that that challenge is especially challenging for people that have limited motor control. So if we can use biological signals to decode what their intentions are, then we can leverage technology to sort of respond and do the actions based on those intentions on their behalf, even if they don't have those capabilities. So especially like control mechanisms for people who have like too little or too much movement. Usually when we have these kinds of conversations, a lot of people like to talk about like locked-in syndrome for people who are living with ALS, especially in the later stages, where they still have complex needs, they have communication, like they are a person, but unfortunately, their body does not allow them to actually, speak or to move and to sort of allow them to have communication with people around them in a fluent way. So I see physiological signals and using it to interpret what their intentions are, so we convey it to be sort of a really key driver in this industry.
That's great, Brian. I know you guys are using EEG electroencephalography. It has also embedded AI tracking, and you're planning to bring more signals into your specific device. Like, can you just share with us, like, why do you think these signals are important, especially for the field of extended reality?
Yeah, so in the virtual reality market, especially for the healthcare market, I think three key feature is major point to making some successful healthcare applications. First one is quantifying self, and the second thing is expert assistant system, and the third thing is a gamification and reward. I think a physiological signal is helping to making some good system in healthcare markets. So the first one, to quantifying self, physiological signals can help to measure the quantified our health information. And the second thing is to making some assistant program or assistant system with it's a kind of telehealth or telemedicine. We can monitoring the users physiological signal and can capture their real-time has informations. And the third thing is for the gamification and reward, we can make a kind of the quantify the reward system. It's not only for the performance-based game scoring, but also we can give some healthcare information-based reward system. I think it is very important to building up the good healthcare applications in virtual reality, and I think keep the physiological signal is a key point in this system.
So it's actually to expand all the information that we already have and to allow people to get access to their inner states. Charles, I know you also work a lot with people with facial paralysis, and you are actually targeting also healthcare applications into that. Like, why do we care to, add some more cumbersome things to something that is already cumbersome, like a big head?
Yeah, that's a really good question. So many companies are focusing, and obviously Lucid and also Cognition are focusing on EEG, and there's a good reason for that, because obviously the brain is what is the main computer of the body. I think consider the face as being the display, the monitor, if you think about the brain as being the CPU. But what's interesting about the face is that it has two connections from the brain. It has the voluntary control. So you issue a command to raise your eyebrows or to smile, and that's one pathway. But there's a second automatic pathway that goes from the emotional centers of the brain to the face. And it's that's really, really powerful. You have these two control mechanisms, both going down the same route. Now, what's interesting about these is that the signals that are emitted from the brain are different based on whether the action is voluntary or spontaneous. Now, the face is unique in the animal kingdom, the human face, because we are the only species with this very flexible, very exposed, naked part of our bodies that we use to interact with people. And we use it to mind read. You know, a baby that's born has no ability to do anything for itself, and it has to communicate with its caregivers in ways that are accurate enough to avoid it dying. So when it's in anguish or in pain or discomfort, it communicates it to the caregivers. And similarly, when it's having a good time, enjoying things, it communicates this as well. And that's why it's so important as an interface between both people and machines. The key thing about the alternatives, which are to either ask people questions or to ask them to click a mouse or do some other voluntary action, is that there's very much less data. By measuring continuously allows one to understand, allows the person to understand themselves, and allows one to get insights that are just otherwise just impossible to achieve. For patients with facial paralysis, one of the things about the face is that you can't see your own face. And so for patients who have been given some instructions in terms of therapy, things they need to do to improve themselves, you can't do that unless you're walking around all day with a mirror. And so having something that's on your, it's worn on your body. At the moment, it's EMG using our VR system, but also we have a glasses-based platform, which will be launching next year, that allows those unparalleled insights to be given to the individual for self-management of not only expressions, but importantly of mood. This concept of valence, which is a term used by psychologists to measure the degree of positivity or negativity. And that's where the huge power is, understanding people's moods, because people can't really understand themselves unless there is a reference point, hence the technology.
And I think what is really challenging right now, what you guys excel on, is to integrate in the sensors. I mean, we have been talking about physiological sensors for many decades, and there's plenty of systems there that you can just buy and wear. But the fact that we are now, in this specific moment of technology development, where a lot of head-mounted displays are coming, and the metaverse that we would talk a little bit about later today is actually really becoming a real thing, makes it like, a little bit more challenging to bring these sensors to headsets that we'll be already wearing when interacting inside virtual environments. And here we have the MTech technology, which is a virtual reality head-mounted display. Cognition works more in the augmented reality head-mounted display. And the Luxury Lab is more like a virtual reality head-mounted display. So, what are the challenges of bringing this as an accessible physiological computing sensors, like bringing those to the head-mounted displays? What makes it already a challenge? What is the importance of bringing this technology into this device?
I'll start. So it's a very complicated question, right? And it also, in part, it kind of depends on what kind of signals that you're choosing to tackle for your, for whatever your company's solution is. So I'll speak a little bit specifically to some of the problems that we kind of encounter as, part of our development process. So right off the top of my head, I can think of three. So I'll go over them quickly, and then we can sort of add a little bit more detail into it afterwards. So latency, and sort of this idea that everything needs to sort of be running in real time to support, navigating through an interface, which is giving you feedback in real time. The second item is sort of this, this dependency to the success of these kinds of applications in regards to the number of like individually selectable items on a screen, and how that's kind of dependent on like the number of consistent, highly discriminable responses that you can sort of collect from the type of data that you're trying to acquire. And then the third item that I think has been a really interesting challenge has been, how does mental fatigue for a user come into play from like prolonged use of mixed reality and with the sensor side? So I guess I'll just speak a little bit about them quickly. So latency, as an engineer, optimization, has to do with a lot of the things that I think about. And mixed reality applications are real-time systems. You're looking and interacting with something, you know, at that time. And in order to have good the decoding and response to a user's intentions, you need to be able to support wearables that can process these signals in real time. And that's really, really, really hard to do in practice.
Is there any number? When, I mean, I know when we talk about real time, we can talk about, like, you know, we're trying to say milliseconds. Somebody's actually asking, is there a number that would say, okay, this is real time because it's, I don't know, this amount of milliseconds?
You know, that's a really fabulous question. And my answer to that is true real time doesn't actually exist, but we do our best. You know, you need time to have your sensors acquire the data, and you need time to process it. And the latency that you can get from, you know, ultimately depends on which type of signal you're using. For us, we really focus at this time in EEG, and that has a very high latency associated with it because of the nature of the sensors and sort of the noise characteristics of the system. You tend to need, like, you have to wait a little bit of time to gather enough evidence for the system to be able to make a decision. And with that added problem that also adds to latency is sort of incorporating the head-mounted display component with the sensors. There also needs to be a synchronization to make sure that they're talking to each other at the same time. So, like, there's a lot of complicated timing issues that can happen in these kinds of systems. And that's a particular challenge that I think is really at the forefront of sort of the problems I'm solving at this time.
Charles, yeah, is there any also, you know, I know we have talked about this from, you know, different points of view. I remember you were talking about the integration of, you know, more sensors, but bringing more sensors, it doesn't necessarily mean like bringing more value or meaningful information. Like, you know, what are you doing with the specific sensors we have already inside the head-mounted displays? What you really care? You know, just want to have your opinion on those challenges.
Yeah, so I mean, so the question about latency is a really interesting one when you sort of break it down to what kind of signal you're measuring. So we're speaking over Zoom just now, and it's been known for quite a few years since they first started doing voice over IP that there's a maximum latency beyond which interactions just don't work. And it's about 150 milliseconds. The reason being that you start talking over each other. And you've experienced that, I'm sure, when you've done Teams or Zoom calls, when the latency is just a bit too long. And, you know, by the time I hear what you said, I started talking and the whole thing goes wrong. So there are fixed quantities of latency that beyond which you can't violate. Similarly, depending on what signal you're measuring, there are window sizes that are mandatory, beyond which, you know, less than which you can't get useful information. So, for example, if you're measuring, so we measure, as well as facial EMG, we measure heart rate and heart rate variability from the PPG, but we also measure breathing rates as well. Now, breathing rate is a relatively low frequency signal, and you need at least 2 breaths to work out what the breathing rate is. And so you can't have a window size that's less than the duration between one breath and another. Well, you can kind of predict where the next one's going to come, but you see what I'm saying? EMG is nice because it has very, you can measure things with very small window sizes, depending on what you're looking at. If you're looking at an expression, in the same way that when you're looking at a word, understanding what the expression is depends on how long the expression is. In the same way that working out what a word is depends on how long the word is. So if I say cat, that's fine. But if I was saying caterpillar, obviously you need to have a longer amount of data to understand what word I'm going to say. In the same way that if I'm activating my cheek muscle into a smile, that's fine, but it could actually be a grimace. So you need to have enough of a window size to work out what the expression actually means. But the fact that the brain response is following what the person has seen and heard cause very automatic responses, a so-called startle response, which can be picked up through EMG, is quite nice because it does give us those insights without having to wait too long to measure the signals.
Yes, Brian, I know you were using BCI, especially frontal lobes, the frontal lobe is a region of the brain to collect EEG signals, and in particular, I know you are using those in a passive way. So you're collecting them and trying to create a specific assistant that would be able to merge that data together with eye tracking and together with the data from the content, and try to bring that information and bring some insights out of it. What are some of those challenges of creating that small device and being able to bring those to commercially available hand-mounted displays?
Yes, I fully agree with the Sarah said latency is the issue. So in that point of view, that's the reason why we combine the eye tracking and the brain waves. So the processing the brain waves and making some real time feedback system is very difficult. So for example, to catch the alpha and beta rhythm and then making some ERP system or P300, the latency we expected is more than 300 millisecond or others. So but the users want to interact in real time. So that's the reason why we combine the eye tracking systems. And in that case, we give a very real time applications just watching some objects and focus on, and we can give some superpower some effect, and that was our first attempt, and in technically is the difficult thing of our company was making some seamless design to attach all the electrodes on the forehead. So all people have a different forehead shapes. So the mechanical design is a very difficult issues. And for example, the foam cushion pushes the electrodes on the forehead foam cushion, but the electrodes is made by the metals like gold or AgCl or others. But it can make pains or some other uncomfortable feelings for the users. So the wearability and the signal accuracy is very correlated issues. So when the electrodes cannot attach on the skins, it reduces the signal accuracy and the signal quality. So we really try to design the comfortable and accurate design to acquire the right signal on the forehead concussion. Yeah.
And I think you all managed to actually bring very interesting design into the devices and all the sensors that you're trying. In this case, Hara is just putting device, she's finished putting some electrodes in the backside of the scalp. Charles is putting the EMG around the face, and Brian, they are putting the EEG electrodes in front of the face. And I find many of the devices, and they are not necessarily as uncomfortable as they might look, but it was also particularly interesting in knowing more about the users, and because I'm not a regular user, I'm not an average user probably of some of the systems that you guys have, and I know you're targeting many different users. So how do they react? Who are the users that you have, and how do they react when they interact with those systems?
That's a fabulous question, John. There's a huge umbrella in terms of who can benefit from the use of AAC devices. For the people that we like, it would be great if we could solve everyone's needs and everyone's problems, but that's a huge ask, because one particular individual's journey through like ALS, for example, is going to look so different from person to person that it's really difficult to sort of capture, to sort of completely tailor and personalize sort of, the best interface to help them on their journey. Of course, we do try to do that, but because we do have a product we need to develop, and we have, we have to figure out, who are going to be the users that really need this right now. We do prioritize like we sort of narrowed our focus, at least for the first generation of the Cognition 1, to individuals with cerebral palsy, especially those that have spastic conditions. So they have a lot of repetitive and generally unpredictable sort of overactive muscle movements. And for those individuals, things like EMG and eye tracking solutions that are often recommended for them can't be used at all because they're always contracting their muscles. So you can't really use that as a control mechanism. And there's so much movement and so much bobbing on the head side that it's really, really difficult for them to use eye tracking. So right now, they have no options. So we are recommending and developing our system to target those individuals who have nothing right now. And sort of on the other side of that of the spectrum, we're also really interested in targeting individuals with ALS or brainstem stroke who have little to no movement at all. So again, eye tracking can help some individuals on that particular journey, but it can't help everyone. And EMG is also a significant challenge for very similar reasons. It's just that they don't make any EMG instead of having a lot of EMG responses. So what can I say? We can meet the needs of these populations in a really tailored and effective way. And then eventually we would like the goal to sort of generalize out to other groups and other sort of use cases and expanding the targets we'd like to help over time.
And I think that's one of the most interesting aspects of this panel is seeing how you guys are trying to create similar devices. It's a head-mounted display plus physiological signals integrated, but you're actually trying to target very different and diverse markets and trying to target specific audiences. Ryan, I know you have been trying to work a lot with older adults, and especially older adults with cognitive impairment. You guys have done a lot of work in Korea trying to, get this sensors to be used as a complementary assessment tool for many different cognitive functions. How is that going? What is the reaction of these older adults when they use your system?
Yeah, so our main user is elder people, and we wanted to develop a kind of cognitive assessment tool and training tool using VR headset, and we wanted to capture the user's cognitive impairments using EEG and eye tracking. And from 2 years ago, we established and we sell our device in to the metropolitan cities in like Seoul and Busan and Daejeon areas, and we tested more than 1,000 people's 1,000 people, elder peoples, and at first time, I'm very nervous about the elder people is not familiar with the virtual reality and brainwave signals and whatever. But the funny thing is, elder people really loves this the virtual reality applications because they did not experience, they have no experience about that. So but the ages like ours, the 22 or 40-year-old people already have a experience about the virtual reality, so that they have a huge expectation on the applications and the quality of the games or others. But the seniors is just expecting the efficacy of these applications, to the if the cognitive training game can help their cognitive ability, and they expect and they can play and they can love the VR environments. So I think yeah, the elder people is suitable and very good users for the virtual reality industry. Yes, sir.
Charles, I also know that you're trying to tackle specific studios and developers that are always trying to find out what their players or users are feeling when they are experiencing this immersive environment. So, how is that going in that specific audience? How do you manage to try to bring these devices with all the sensors and all the biometrics jargon that we have into that world that is, very pragmatic. They need insights right away.
Yeah, so it's a very interesting field because there's a parallel with my day job as a doctor, because ultimately you're trying to understand people's feelings and to help them do the job that they're trying to do. In the case of healthcare, you're asking somebody a series of questions, and then you're going to hopefully give them a prescription. In the case of the developer, you're trying to understand your users so that they can enjoy the game or experience a piece of content you've created. So there's a core problem that needs to be solved. How can you understand the person without having to go through asking questions, because questions are biased and subject to recall and memory and social filtering of responses.
Disruptive. I mean, they really disrupt experience. When your experience is something and you ask,
yeah, exactly. And in VR, clearly, if you're creating an immersive experience, the last thing you want to do is say, hold on a second, excuse me, how are you feeling now? How are you feeling now? How are you feeling now? You don't want to do that. So the ability to give not only continuous information, but also implicit information, that is to say that it's not going to be filtered by sort of politeness, for example, saying, hey, your game sucks, I think is particularly valuable. And to de-risk the process so that people don't spend a lot of time and effort launching something that ends up failing. It's exactly the same problem that's in healthcare. We have billions literally spent on treatments for depression and other conditions. And how do we test them? You say, how are you feeling? It's ridiculous. You want to actually understand objectively how people are responding. So we have some collaborations with, in fact, we have, I'm not sure if I can say it, it's under NDA, it's quite a big collaboration with the university on the continent, where they're looking at VR and how it can change behavior. We're doing a really interesting project with an amazing content production house called Atlantic Productions in January of next year. They've made some amazing experiences for the Quest and for other environments. And also a big collaboration in Q1 of next year with a big company that does entertainment. And the reason why we're doing that, even though we have a healthcare background, is because it really gives an understanding of how people just behave normally. Understanding normal is key to being able to help people when things are not going to plan.
That actually gives me a nice introduction for the following question, because we're talking here about developers and creators. And in order to really unleash what the real capabilities of your devices, you really need to work on the allowing those and integrate into tools and allowing those tools to be out for them to be able to create their own applications. And I've seen many different UI elements and many different processes that you're trying to bring into your devices to actually allow developers, creators, designers to create experiences using those specific systems that you guys are creating. How is that going? How do you expect the people to adopt your technology, especially the creators, to start creating experiences for others to use?
Yeah, well, I mean, obviously you yourself was at the vanguard with your excitometer, and one of the reasons why I reached out to you was of that project. And for those who don't know, John developed a tool set and framework to allow one to measure exercise responses, physiological signals in VR using heart rate sensing. And I think that's a really great example where somebody could have a Peloton type experience within VR, and you really wanted to measure how people are actually engaging, not just their physical actions, but also their physiological actions as well, because you can use that both as monitoring, but also to input into the game. When the person's getting excited, you can either turn the excitement up, make it even more scary, or turn it down, make it less scary. We have a collaboration with a developer in the Netherlands who's making a horror game. And that's really, really exciting for us, because it means that we can now use the signal to test, is that game actually scary? So you can modify it, improve it, but then also use the signals to adapt accordingly. So if it's getting too scary, maybe turn it down a bit so it doesn't become unpleasantly so. And if it's not scary enough, turn it up a bit. So those are the ways. And we recently launched the XR Research Awards with some collaborators, with Pico, with Flux Biosignals, and with Cognitive 3D, to help to kickstart this process of people, content creators, developers, and researchers to use objective measures rather than questionnaires and surveys to measure their content, to measure their experiences more objectively. And that's open until, I think, another week until it closes. That's xrra.net is the website. And entrance are open. There's a €40,000 prize pool for those hardware plus some support financially.
And I think that's part of the strategy, isn't it? Like allowing others to be able to access the technology and to eventually gain some initial seed funding to start their own ideas. In your case, Sarah, like I know you are more in the assistive tech side, and there's a lot of companies and studios and developers trying to create like real good applications and usable applications for these people. What are you doing in Cognition, guys, to, I don't know, bring in an SDK, an APA for integration with, I don't know, the iPhone and all the devices that people are already using?
Yeah, totally. So, we are really focusing sort of the communication space because we are a communication sort of company. Like that's where we're sort of really positioning ourselves in the industry. But it would be absolutely silly for us and not too bright if we were to say that we were to only sort of support the end users and to not recognize that there are opportunities in research. And research is a big umbrella. Research can mean a lot of things, and researchers mean different things to different people. So the approach that Cognition is taking is we're really focusing to be like bleeding edge and the best at this at the sort of AAC communications. But we recognize that there's a lot of other talent out there and a lot of really incredible developers with great ideas who could also be taking our technology and helping other people. And we're not going to keep them from doing that. Like, we're here to help people. So, so we are absolutely planning on providing support for developers and for researchers. So we were sort of focusing on, we're still sort of figuring out sort of the ultimate list of like what features and what like third-party library support do we want to offer and all these things. We're sort of at the time sort of focusing in on two interesting communities of researchers. One being very much like interested in the open BCI hacker space and like going to these neurotech themed hackathons and like, here's a bunch of hardware, do something cool. There is a theme. So we do want to provide support using libraries that people are already comfortable and familiar with. I don't feel comfortable sharing exactly which ones at this time, but that is the approach we're going to be taking. On the other side, there's a lot of incredible talent and a lot of great work being done sort of more on the interface side. So I know that the Games Institute is really like renowned in this space. And there's also the Advanced Interface Design Lab, I believe it's called. So we also recognize that there's a lot of opportunities in sort of the application side. And we also plan to provide support and SDKs for individuals to be able to take what we've already done and all that work and incorporate it into new applications that they may be able to sort of work more closely on the user side of things and sort of continue endeavors and research in sort of that space.
That's what I'm saying a lot of you guys are trying to do with the headsets and the devices that you're developing. Brian, in your case, I know we have talked about, the creation of this SDK to facilitate people to really start using brainwaves to create more and more brain-powered games. You are now like evolving this concept of Lucy as an intelligent agent to facilitate all the process of collecting and synchronizing this data. What are you guys envisioning there in terms of tools to empower creators to use your device?
Actually, 3 years ago, maybe 2018, we opened a kind of challenge for the researchers and the developers. And at that time, we developed the Lucid VR and eye tracking and brainwave in combined and integrated VR headset we made. And the challenge was the many researchers and the developers giving some ideas. And as I remember, more than 80% of the content creators or researchers wanted to building up the healthcare applications, and the other 20% of people wanted to develop a kind of superpower like games, and it's a game interface, just a game interface. So I think the both side is makes sense, now we are building up the healthcare application by ourselves, and but we will open the SDK, maybe the next version of our link, the hardwares, and I think the expectation is there are three types of researchers and the creators. First group wants to access. They want to access to the low data, just low data, and they are all the researchers, and they want to building up the signal processing algorithm themselves on the other things, and making some real-time processing system in virtual reality, and they can connect their algorithm to the contents. And the second layer is that they want to access to the features. They don't know about the low data or signal processing, just to access to attention, relaxation, or whatever they want to capture the user's mind. So the second layer is almost have an idea about the contents or other gamification or some whatever. And the third layer is analytics index. So the gathering all the data and making some statistics analysis and giving some report. But it is very difficult. But some people misunderstanding the signal processing and the signal analysis process, so that they believe just capture the data and they can diagnose the Alzheimer's disease or ADHD, whatever. So I think developers have to know what information or what data they wanted to capture, and then they wanted to analyze, or they have to think about this device or this SDK is suitable to making their system. So I think
it's definitely something has happened to me all the time, this misunderstanding on the signals and what the signals can tell us, and the high expectations about what EEG can tell you about somebody using a specific experience. And I think we all have been feeling that, especially you guys dealing with the devices and all the signals and trying to bring a cohesive pitch to the investors and to the people to actually understand and grasp what the signals can do and what cannot do. And what I'm trying to bring here is, I know you guys have been trying constantly, and you have been around for a couple of years now. And there's always this question of, how do you keep your business alive? How do you bring more investors to keep growing the devices that you were doing? And I'm seeing like lately Cognition, and I actually would like to congratulate a Cognition team because they raised a very decent amount of money to keep going with their device. And I think it has been happening also to Brian and Charles at different stages on their development. So how do you guys are, doing your business model? What are those, the value propositions, what are those users, resources that you guys are doing right now? How do you do with the chips shortage that we have right now? The personnel, people are constantly moving from one place to the other. The developers are in shortage as well. So how do you deal with that, mess and complications are?
I delegate it to someone else, and it's not my problem. Those are really good questions, and I really wish I had a nice snappy answer that could fit into a panel response to that. The chip shortage is I think hitting everyone really hard right now, and I think if we had found a good solution that everybody would be doing it. You do your best, you sort of plan for the worst but hope for the best. So early on, like we've been in this COVID stuff for a year and a half now at this point. So we looked at our roadmap and sort of decided early on that that, you know, when the pandemic came around, like we knew that there was going to be pretty big consequences, especially in terms of manufacturing and in shipping the hardware to the places it's got to go to be assembled, and all the complicated things that get involved as part of like the manufacturing process. So, you know, we've done our best to sort of predict and stockpile. So I think that we're in a pretty comfortable place, like internally at the moment, in terms of, are we going to be able to, you know, to provide headsets to people, especially for sort of our prototypes and our 1.0. So I think we're sort of okay on that. I think something that I really want to sort of talk about, and sort of where the value proposition for our company lies, because there's tons of BCI companies out there, like they're popping up out of research labs every day. But Cognition has always positioned ourselves as an assistive tech company first, and everything else is a close second. And I think that's really important because something that I really learned about EEG-based wearables, being in this industry for some time, and also like, you know, being a researcher and having to work with the devices, is how many of these devices are sort of built up out of research labs. And the value proposition coming from that kind of perspective is that the novel technique or the paradigm is in like identified research published in these research labs, and then the company spends, you know, gets some funding, gets the companies, you know, started up, and then a lot of time and money and resources is spent trying to find the problem that the solution you made can be applied to. And I think this approach really lends itself terribly to the accessibility space, because really complicated solutions are kind of being poorly justified for the problem spaces that they're trying to address. And by sort of taking the other approach, where we're not a neurotech company, we're not a BCI company, we are an assistive tech company. We didn't alienate the human side of the problem space, which is something that I kind of see happening, not with every company. Of course, there's always exceptions to the rule, but there is a concerning trend from my perspective. And it kind of feels like people are trying to fit the cube into like a circle-shaped hole. And part of that process ends up causing a lot of like cut corners, trying to like make it fit. And I think that the accessibility space has been around, and it's a little bit mature for just long enough to be able to be like, oh, I think they're kind of pulling our legs, and like, this is probably not the best fit. So that's sort of the value proposition that Cognition's taking for solving accessibility problems.
Charles, I know you guys have been also pivoting between different markets and target audiences, and starting healthcare and moving here and there. Like, what are you guys doing right now? You know, trying to keep your business alive and trying to bring more features to your headset, and, you know, building out features is always very challenging when creating these devices. So how is it going for you guys?
Absolutely. I mean, our core mission has always been the same, which is, you know, we believe that face-to-face interaction is fundamental to humanity, and understanding, providing an understanding of intentions and emotional responses is core to the future of interactions. To do that, obviously, we start with those with the greatest need right now, and those with the greatest need at the moment, who also have budget, are researchers, because they need high quality data. They understand raw signals and can handle the system as it currently stands. But we're now building tool sets that will allow non-specialists to use our system to do their own job of understanding how people are interacting with their content, but with the longer term vision of enabling it for individuals, for self-management of anxiety disorders, of depression, in collaboration with content creators, because we're not going to be focusing on making our own content. Because of our novel approach, we have been fortunate to have attracted quite a lot of investment from government sources, both in the UK and elsewhere, to fund R&D programs, and that's kept us going thus far, which is useful, because it means that it de-risks it when it comes to investment. So we create the proof of principle, we show that it works, and then we get equity-based funding to go forward. We're very lucky in that the industry's kind of caught up to the ideas we had, 8 years ago. I thought the company's been formed 6 years ago, but obviously I started it before then. The industry's kind of caught up to those ideas, and recognizing that with the metaverse, of course, people will not want to have a blank face. You want to have an avatar that actually expresses and interacts. And so I think that our technology will have a place in that future metaverse. And there'll be more than one company who'll be working in that space, I'm sure.
And I'm pretty confident that you will be always pivoting on different ideas and try to, collect as many users as possible for the type of device that you guys are creating. And O'Brien, you are now trying to tackle one of the most aggressive and challenging markets, the US market, and you actually recently did a trip to the States, and you have been trying to engage with more and more people there, especially senior care facilities. So what you have a mix of funding from Korea, people in the States, and different investors. How is that going? The business model, how is that going for you? How are the plans to bring your device to the States?
From 2 years ago, we prepared the healthcare market. The first we focus on the Alzheimer's disease and cognitive assessment and the training system, because there is no pill or no cure program for the Alzheimer's disease. So the only solution is detecting the cognitive impairment earlier and training them very effective way. So in South Korea, we established the cognitive assessment program and the training program in the local side. So in the metropolitan city, there is a hospital, but a lot of people cannot access the public health. So we are now distributing our VR headset and solution in the local side, and in the local side, the seniors can play the VR games, and we can give some report of their cognitive ability, and then they can catch they can check their cognitive ability and training themselves. So last year this year we starting the sales of the Lucy, and we successfully selling our Lucy solution in South Korea, and 3 weeks ago we closed our funding, and the major investor was an insurance company. Insurance company really how can I say, they really interested in prevent and predicting the Alzheimer's disease, and they invested this technology and our solution. And next step, we are now designing the metaverse systems, because we sold the solutions, and the seniors really wanted to conversate in the VR environment and interact with others and other things. So we are now building up the metaverse system, and we wanted to establish the healthcare system in metaverse world. So now we are preparing that kind of application in South Korea, and we wanted to expand the US market or Canada and other global markets with our solutions.
Yeah, you're actually jumping to the last question that I had, which is perfectly fine. And that is certainly related to, how do you guys are now envisioning the role of this affecting of physiological computing in building this new metaverse and Web 3.0. And I got this the specific diagram from Matthew Ball, who was trying to bring the core enables of the metaverse. So what do we need to be ready to actually be able to start building this and start connecting things? And over here, I see things like Hasware, I see things like the virtual platforms being actually very much into the DNA of what you guys are trying to build, which means Hasware that is integrated into this virtual environments where people can express, where people can, get more from what they are used to have regularly in a Zoom call or in a Facebook or in a conventional game application. So how do you guys see yourself in a couple of years when those applications start like really exploding and bringing us? And Brian, you mentioned already trying to kind of like build this metaverse for psychological well-being for all the adults, which is more or less what you guys are planning to do in Lockheed Labs. Charles, what is the type of system? How do you see your company having a specific role into that?
Yeah, good. The South Korea is crazy for the metaverse, and then the government's crazy about the metaverse, and that they want to get the pioneers. They want to be a pioneer of the metaverse systems, especially for the healthcare systems. They really want to building up the metaverse system in mobile and the VR, and they connect the mobile and VR also, and they believe that they can establish or they can building up the virtual hospital in the metaverse, the virtual reality world, and that they can give some remote the telehealth using that kind of system. In this situation, the problem is that using the virtual reality, they cannot capture the patients or the users real-time status or the healthcare information. So using mobile phone, we can capture the faces of the users, but in the virtual reality, they cannot capture. So I think the physiological signals like EEG and the EMG or heart rate and eye tracking, it is a very helpful solution to capture the remote place the users or remote place the patients information. So I think the role of the physiological computing in the metaverse is something like that. Yes, sir. Thank you.
Very promising. Charles, you were about to say something about this specific topic.
Yeah, I think that the metaverse represents a merging of digital and physical worlds, and what we're doing, all three companies here, is creating the interface that will take what are basically digital signals. Nerve firing is, it's either firing, it's not firing. That's a digital signal of sorts, and we're translating it into the digital world. So we are very much at that boundary between the physical world and the metaverse. In our case, understanding preferences is key to optimizing experiences. We have this vision. Many of you will have seen this video, which is online on Vimeo. It's called hyperreality, and it's a vision of augmented reality where the whole world is painted with data, and it's a dystopian nightmare. And to avoid that, which would cause terrible accidents with people getting distracted by what they see, to avoid that, you really need to understand the individual. What is it they want to do, and where should their attention be focused, and what their preferences are, because that way you can give them, for example, a notification when they need it, not all the time. Many of you on the panel are too young to remember a thing called Microsoft Clippy, which was a little paperclip that would appear as a notification on your computer to kind of say, hey, you look like you're writing a letter. That was really, really annoying. And what people don't recognize is that VR and AR represent a very different paradigm than a smartphone, which is a small thing that occupies a very small part of your field of view. When your whole field of view is under control of the content creator, it's really important that the experience is optimized and personalized for that person. And that's where our technologies come in.
And I think, Sarah, in your case, it's even more important because it's actually giving access to this new universe to users that probably would never be able to interact in that way. So how do you see yourself or your specific company as a company to empower those specific people with those communication disabilities?
So I should start by saying we call our device an AR device, but we don't usually call it an augmented reality device. We call it an assistive reality device. And I think that really plays well into like the whole concept of Web 3.0 and how we envision our device and its role in this larger, complex, decentralized, data-driven buzzword system. I think that the thing that I'm most excited about and sort of where our contribution is going to be in regards to like this transition into Web 3.0 is the idea of sensor fusion. So like, and I think that our colleagues here have done a great job sort of capturing it. And this idea that you can make more informed, personalized, advanced decisions about people and what they want by using sort of different types of data. And in this case, I mean sort of like different quantifications, like different types of sensors that represent maybe different aspects of your needs or your wants or your health, as opposed to like different like sources of data. I think that there's a huge, like it's going to advance extended realities in ways that we can like take advantage of, especially in the assistive technology space. A lot of people think about these this kind of physiological computing opportunities in the context of gaming. I feel like some of the challenges that we've sort of already captured here today in this panel sort of demonstrates where we are with that in terms of how far we can go today. But I think there's so much opportunity in the assistive space that right now we could be providing for them today is really, really important. And for example, our headset is focusing sort of on this AAC communication speech generation problem, but we are also interfacing with other technologies and other things that are going on in the environment in the room and enriching the capabilities of the language system by engaging, for example, the circle of care around the user or patient in this case, if it's clinically relevant for like a speech language pathologist, for example. And that's going to have huge contributions in sort of allowing the user that's using our headset to achieve fluency using these assistive devices like way faster than ever before. And also, we can, now everyone has like a personal assistant in their home. Most people have at least an Amazon Alexa, Google Home, the other one that I can't remember off the top of my head. But there's such an enrichment of communication and control there. And our headset absolutely intends to provide support for home automation and using that to support not just the communication side of the opportunities that Web 3.0 provides, but also for control. So that's one particular aspect of it that I'm really excited about.
And I think in order to get to that moment, you know me guys, yeah, I'm a researcher. I'm always looking to, what is the research question that we're trying to solve with all of this development of these devices. And I would like to take, the last question. I know you are all coming from a research background. We are all coming from a affective research background. And I just would like to know, just briefly before going to the question, is how do you use the scientific research and the scientific insights to actually drive and shape the product that you guys are creating? And I know you are also hiring people. So what are those skills that you guys are looking at for people? Really quick before going to the questions and answers, Brian.
Yeah, actually, there are a lot of Unity engineers, like game developers and the prompt client developers or software engineers. But I think there is not sufficient number of people can develop the physiological signal-based game design or game developing and the real-time processing and then making some content. So that we are now hiring many people to develop our contents, but the first condition is they can develop and managing the biosignals and like physiological signals. And for the scientific researches, actually we cannot do all kind of the clinical researches or pilot studies about all the diseases like ADHD or Alzheimer's or whatever. So we really want to work with the researchers who wanted to develop the games to assess to give diagnosis or training some of the disease or some mental health problems, or And if some researchers want to help solve the kind of problem, please contact us, and we really work with you guys. Yes, thank
Charles,
you.
I also know that you're constantly looking at different scientists and people with different skills to try to bring them to your team and develop all the things that you're planning to develop. How's it going? How's the research going on your side? We actually met because of the research you guys wanted to do.
Yeah, absolutely. Yeah, I mean, above all else, we really love working with passionate researchers such as yourself. As Brian said, finding people who are well used to working with physiological signals is not easy. It is, our belief that with the correct vision and mission in terms of the longer term vision for healthcare, it's a law of attraction. People come to you, and we've been really lucky. We've worked with some great researchers in some leading universities, Cambridge University. Just recently started some work with UC Berkeley. And in fact, we've got an advert out just now for computer vision scientists who wants to do work around digital avatars. It's a really, really important part of our journey to work with researchers who are at the cutting edge of machine learning, data science, physiological signaling, signal processing, etc. And it's only through collaboration. We met our amazing data science team through, in part, providing some data sets to the public domain in research for a competition. And the brothers Christian and Martin Gajewski, they knocked it out of the park in terms of the scores they were achieving for activity recognition from sensor signals, and that they're now a full-time part of our team. We're always on the lookout for bright scientists, researchers, people with passion who want to do something impactful on the world.
Well, please feel free to share. So Sarah,
I know we're really short on time, so I'll just jump in and say my 2 cents. We are hiring, as John said, we close a round of funding. We are hiring. Please come look at our website, cognition.com. We're hiring such a wide range of skills and expertise that it's really difficult to just focus on the one. We like marketing, user experience design, a lot of different engineering roles all over the board. Look at our website, apply, please. We are looking to grow. In terms of sort of the role that scientific research plays, we do have collaborations with various labs all over North America. And we also have created our own our little bubble of science, of influencers, scientific researchers, and we call them our Brainiac Council. And we use this council meetings to really engage with researchers and influential people and people who are just really invested in the problem we're trying to solve. And we use that as a soundboard for important ideas or important themes that we really want to make sure that we hit. And so we get immediate feedback, making sure that we're actually solving the problems that are important to researchers, clinicians, and users, and that we're solving them right.
Well, with that being said, thank you all of you guys for coming to this fantastic panel. Thank you, the CDV and the Games Institute, for hosting this. We got a couple of questions here. Agata, if you want to also help me here with the wrap up. Thank you, Charles, Ryan, and Sarah, for coming here. We are a little bit delayed with the time, but time flies when you talk about signals, headsets, applications, market, and I know you guys are so passionate about the type of products and system that you guys are trying to do. So thank you for coming and sharing all your opinions and all this amazing insights that you guys have while creating this new generation of these devices.
Absolutely. Thank you very much, John, for moderating today. And I will join John in saying that it's not easy to finish a conversation in 60 minutes with so much to be said and such a wealth of information and knowledge here coming from our industry experts. I will say that I was looking through the list of participants, and we had both Games Institute and CBB members here, including some faculty members as well. So Sarah, Charles, and Brian, expect some emails flying your way saying, I have this idea.
Looking forward to it.
Yeah, I had also promised to put some links in the chat there. There are links to CBB and Games Institute. We obviously are active on social media, Twitter, Instagram, LinkedIn. So please do take a look for those of you who are new here. And my thanks again to John for moderating today, but also in particular to Brian. Brian, you are in South Korea. Thank you so much for either staying up super late or waking up really, really early. And so if right after we finish up, I hope you can catch up on your sleep here. Charles, I believe you're in the UK, so you have a wonderful evening. And Sarah, are you in Toronto or in Santa Barbara?
Right now I'm in Toronto.
In Toronto.
If you asked me last week, I would have had a different answer for that.
Okay, well then someplace in between the time zones.
Somewhere. I'm somewhere in North America.
I hope you will have a good afternoon. And yes, if anyone has any questions, then the CBB and the Games Institute are here to help. And I was thinking about that metaverse thing that you were all talking at the very, very end, and John had a gorgeous graphic there. This one, thank you very much, John. This very much brings me back to the core of what CBB and GI are trying to do, which is interdisciplinary research and very fruitful and very collaborative activities with partners. So I encourage all of you here in the audience and also our panelists to think how we can all work together. And I know that the Games Institute, and I'm pretty sure CBB as well, will do whatever we can to put you in touch with the best of our researchers. And with that, thank you so much for joining us. John, Sarah, Charles, and Brian, I cannot thank you enough for participating today. I will let you also know that the Games Institute Executive Director, who has been watching, said that as soon as the recording is ready, he's sending it to our Vice President of Research in International. So he is very, very proud of this panel, and thank you very much to our colleagues at CBB for doing all of the logistics in the background and for letting us co-host today. With that, have a good night, good afternoon, or good morning, depending where you are. And I hope to see many of you again. Thank you.
Thank you.
Thank you.
Bye.
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 See you.